Hello there. We're going to practice converting a sentence into various logical formats and the twists and turns that can come there. So first we're going to need a statement. So for this first one, let's work with the statement all Trevins are divisible by 3. The conditional, that's going to be the standard if-then statement. So for this one, we'll start it off with if a number is Trevin. So I'm going to start with Trevin here because I had Trevin here. If a number of Trevin is Trevin, then it is divisible by 3. For the converse, I'm going to switch the order of the condition of the hypothesis and the conclusion. So if a number is divisible by 3, then it is Trevin. For the inverse, I'm going to refer back to the condition and negate both the hypothesis and the conclusion. So if a number is not Trevin, then it is not divisible by 3. And then for the contrapositive, you negate this one and then follow it with the negation of that one. So if a number is not divisible by 3, then it is not Trevin. And we can think about which of these statements is true. Accepting this statement, well, we of course want the conditional to be true. And for this case, the converse, if a number is divisible by 3, then it's Trevin. That's true. The inverse for this one is also true, and the contrapositive was true. So all of those are true, so this one actually works both directions and can be written as an if and only if statement. So a number is Trevin if and only if it's divisible by 3. Okay, so that one was kind of nice. Let's do another one. Let's make this one not math related. Good old Spock. Spock can solve any problem he sets his mind to. Turning this into a condition, we have to be a little bit careful. We need to turn this statement into an if-then statement. So I'm going to do this one is if Spock can set his mind to a problem, then he can solve it. Okay, converse. I'm going to switch that order there. So this one's a little bit tricky because of the order of these events that you normally want them setting the mind to it before solving the problem. So I'm going to write this in a different tense. If Spock solves a problem, then he set his mind to it. And next up, the inverse. So this is negating the order here. If Spock sets his mind to a problem, if Spock doesn't set his mind to a problem, then he cannot solve it. And lastly, the contrapositive. If Spock doesn't solve a problem, then he didn't set his mind to it. So let's look through which one of these are true. Accepting the premise here, Spock can solve any problem he sets his mind to. The condition, if Spock sets his mind to a problem, then he can solve it. That is certainly true. The converse, however, if Spock solves a problem, then he set his mind to it. That doesn't need to be true. And maybe it's so trivial that he doesn't need to set his mind to it and he can just do it. Or the inverse, if Spock doesn't set his mind to a problem, then he cannot solve it for the same reason. That doesn't need to be true. And lastly, the contrapositive, if Spock doesn't solve a problem, then he didn't set his mind to it. Poor Spock, he should have tried harder. Okay, so that one is true. So in general, the converse and inverse do not have to be true for these statements, but the conditional and contrapositive are always going to be true as long as the conditional or the premise is true. Over on this side, we had that they were all true, and that was because it worked both directions and worked as an if and only if statement. All right, hopefully Spock will always set his mind to solve problems. Character and Scholarship for Life.